Hi everyone, this is your Unit 3 test review video over the absolute value functions. This test will include things like solving absolute value equations and inequalities. You're going to have to graph those solutions on a number line. You're going to have a few word problems where you're going to have to solve absolute value equations and inequalities. And there is a graphing portion where you have to be able to list the key features of absolute value graphs and talk about their transformations. So the first section is solving absolute value equations. If you see this symbol, the equal sign, that means that you should have no shading and no number line, okay? So the way that you solve these is make sure that your absolute value bars are by themselves, and in this case they are. There's nothing in front of it or behind it. So I'm going to break it into two separate equations. One of them looks the same without the absolute value bars, and the other one has a negative 12. So you are not changing the sign that's by the 5, so you're not changing it plus 5 minus 5. You're changing the number after the equal sign and making it positive or negative. So on both of these, it's the same procedure for solving. And I get x is 7 over 2. You can just leave it like that. You can give me the decimal of it. I don't really care either way. Okay, so we get 7 over 2 and negative 17 over 2. Notice that I got two solutions for this. All of your absolute value equations and inequalities are going to have two answers, so make sure that you give me both. If you type it into NSolve on your calculator, it's only going to give you one, so you're not going to get full credit for the problem. Okay, let's move over to number 2. So I need to get rid of this plus 4 that's here, and I need to get rid of the 3 that's in the front. So picture this kind of like 3x plus 4 equals 10. If you were solving this, you would subtract 4 from both sides to move that over first, and then you would divide both sides by 3. So I'm going to do that same thing here. I'm not going to distribute the 3 into the absolute value bars. So if I subtract 4 from both sides, get 6, then I'm going to divide both sides by 3. And these are going to cancel. So now that I have the absolute value bars with nothing in front of or behind them, I can break it into two separate equations. One with a positive 2, one with a negative 2. And then I'm going to solve for x on both of them. So one of my solutions is 4, and the other one is 0. I noticed that a lot of you on your last test, when you had something like this, you put like no solution, or you crossed it out, or you thought you were wrong. It is okay to get an answer of x equals 0. That's totally fine. Okay, number 3, writing an absolute value equations that has no solutions. So your definition for absolute value is the distance that a number is from 0. So distance can never be negative. So any equation that you write where you have the absolute value of something is equal to a negative number, that's going to have no solution. So for example, if I had like absolute value of x equals negative 7, since there is this negative sign in front of the 7, that is what's causing it to have no solution. So anything in those absolute value bars goes, but if there's a negative on the other side of the equal sign, that is going to cause you to have no solution. Okay, let's look at solving and graphing inequalities. So your process for solving is very similar. There's just the graphing component and the flipping of the sign. So this is kind of like solving 2x is less than or equal to 10. To tackle this, you would divide both sides by 2. So I'm going to do the same thing here. I'm not going to distribute. I'm not going to subtract 2. I'm going to divide by 2. Okay, then I'm going to break it into two separate inequalities. So the first inequality, I get rid of the absolute value bars. The sign and the 5 stay the same. On the other one, I need to flip my inequality symbol the other way, and I need to make that 5 negative. Then I'm going to subtract 4 from both sides to solve it. So I get x is less than or equal to 1, and x is greater than or equal to -9. So when you graph this, I'm going to put -9 over here because it's smaller. I'm going to put 1 here. Since this symbol has the inequality with a line under it, this represents a closed circle. So these are going to have closed circles around those points. For the shading, this says that x is less than 1, so I would be shading in this direction. And then it says that x is bigger than -9, so I'd be shading in this direction. So my overall shading is going to be in between those 2 points. So if you're looking for your inequality notation, that will be a part of your test question. When you have shading in between 2 points, you put x in the middle, and then whatever inequality symbol that was in your problem, it's always going to face in that direction. So it's always opening with the mouth going to the right. I'm going to put the smaller number on the left side and the bigger number on the right side. Okay. Number 5, I need to get that -3 away from the absolute value. So I'm going to add 3 to both sides. Okay, now I'm going to set up my 2 separate inequalities. One is going to stay the same without the absolute value bars. The other one, I'm going to flip the sign and make that a 11 negative. I'm going to add 1 to both sides. Oops. Okay, so I've got that x is bigger than 12 and x is smaller than -10. So I'm going to put those on my number line. -10 is smaller and 12 is bigger. These symbols do not have a line underneath of them, so that's going to represent an open circle. So these are going to get open circles around them. For my shading, if x is bigger than 12, I'm shading in this direction, and smaller than -10 is shading in the other direction. So you're going to have shading on the outsides here. Okay, whenever you have 2 separate sets of shading, the symbol that goes with that is the union symbol. Okay, that's that letter U. So you're going to write the smaller number, then you're going to put that U for union. That represents the gap in your graph between -10 and 12. And then I'm going to put my larger number. So that would be my inequality notation for that one. Okay, number 6, I need to subtract 8 from both sides. And then I can split it into my 2 separate inequalities. Then I'm going to subtract 4 from both sides to get the x's by themselves. Okay, so I'm going to plot -11 and 3. The symbol here has a line under it, so that's going to be a closed circle around these points. And this says that x is less than -11, so that's shading in this direction, and x is bigger than or equal to 3, so I'm shading in this direction. So I've got shading on the outsides. So since I have 2 different things that I'm bringing together, think like marriage, I'm going to put that union symbol in my inequality notation. So you're going to have the smaller number of -11, the U for union, and then the larger number of 3. And that's your inequality notation. So your questions for the inequalities should have 2 pieces to your answer. You should have your inequality notation, which is this, and then you should have the shaded number line. Moving on to word problems. We have the equation listed here for you. And then this one down here, this really should say, whoops. This really should say x minus target is less than or equal to varies, not equal to. This is just a typo, okay? So basically the purpose of these is determining what the target is and what the varies is, and then writing your inequality or equation and solving it to figure out how much can you vary depending on the situation. So for number 7, to conserve energy, Northeast ISD has determined to set the thermostat at a certain temperature year-round at all athletic buildings. The accuracy of the thermostat, so the tool that's measuring the temperature, varies 3 degrees. So that right there has given me a piece of information that my varies is 3 degrees from the target temperature of 81 degrees. So that gave me my target. So I'm going to start with this equation. I know that my target is 81 and my varies is 3. So I'm just going to substitute those two numbers. So when I'm solving, I'm going to break it into two separate equations. One of them has a positive 3. The other one has a negative 3. Then I'm going to add 81 to both sides and solve. I'm running out of space. So you're going to get from this one, x equals 84. And then from this one, you're going to get x equals 78. So that means that your temperature is going to be somewhere between 78 and 84 degrees. So you just have two answers of the 84 and the 78. There is no inequality symbol here, so you do not have to do the graphing on a number line. Okay, I'm going to erase the bottom part because it's in our way. Okay, the next question, a candy manufacturer puts 240 pieces of candy into each bag. So that's an important piece of information. The bag can be off by 8 pieces. So it's just given me my 240 is my target, and then my 8 pieces is my varies. So using this formula, if you're wondering about the inequality symbol that's there, it's always going to go in that direction. That inequality symbol is never going to like face the other direction. It's always going to be going that way. So my target is the 240, and then my varies is 8. So I'm going to set up two separate inequalities. Okay, then I'm going to add 240 to both sides. So one of my solutions is that x is less than or equal to 248. The other one, x is bigger than or equal to 232. So this one, I do have a number line that I need to plot since I have an inequality symbol. So the smaller number of 232 is going to go here. The bigger number of 248 is going to go here. My inequality symbol goes with a closed circle. So I'm going to put closed circles around here. I have that x is smaller than 248, so it's going in this direction. And then x is bigger than 232, so I'm going in this direction. So I'm going to have shading in the middle. Pretty much all of your real world inequality problems, you're going to have shading in the middle. So if you're writing your inequality notation, since there is shading in between two numbers, that means that x goes in the middle. Your bigger number of 248 goes on the right, and the smaller number of 232 goes on the left. So that would be your inequality notation. Okay, for number 9, there's a typo here as well. This should not say stretch, this should say compression. Okay. So this question is all about you building the equation given pieces of information. So you were given that your parent function is the absolute value of x. You were given that you're going 4 units to the left, you're going 1 unit down, and you have a vertical compression of 1/2. So I'm going to start with y equals, and I'm going to put an x somewhere in there. That's just, you have to have the absolute value of x somewhere in there because that's your original parent function. So if I want to go 4 units to the left, A movement left or right happens inside of the absolute value bars, so I know I'm going to have a 4 here. Remember the trick that x lies? So if I'm going left, you usually associate that with a minus, but x lies, your sign always flips, so this is going to become a +4. If I'm moving 1 unit down, a movement up or down happens in the back. So you would have a +1, sorry, you'd have a -1. And then you've got a vertical compression of 1/2. So a vertical stretch or compression happens in front of the absolute value bars, and I'm going to put a 1/2 here. So that would be your equation. Number 10, we've got the same parent function. So I know I need the absolute value bars somewhere in there. It was reflected over the x-axis. We went 2 units to the right, 3 units up, and a vertical stretch of 2. So that's a lot happening. So I'm going to set up my equation. Okay, if I am reflected over the x-axis, that means that you have a negative sign in the front somewhere. So I'm going to put a negative sign here that stands for that reflection over the x-axis. Reflected over the x-axis means that your graph used to be facing upwards like this. Now it's going to be going downwards like this. Translated 2 units right, so a movement left or right happens inside the absolute value bars. X lies, so if I'm going right, this is going to be x minus 2. 3 units up is going to happen in the back of the function, so you're going to put a +3 in the back. And then a vertical stretch of 2. A vertical stretch or compression goes in the front of the absolute value bars, so you're going to have a 2 here. So that would be your equation. This last section revolves around graphing. So the way that I like to do this is to find my vertex first and then label my other points. So the first thing that I'm going to look for is this number and this number. They represent H and K. The sign of H always flips, so H is not +2, it's -2. And the symbol or the sign in front of K stays the same. So my vertex, where it asks you for vertex here, that's going to be at -2, 3. And I'm going to put that on my table. And then I'm going to plot that on my graph. Okay. From there, the number that's in the front, so this -1/4 here, that is showing you your slope. So that means from my point, my vertex, I'm going to go down 1 and over 4. So I'm going to go -1, so down 1, over 1, 2, 3, 4, and put a point. And then the same thing on the other side. And then you're going to connect these with a straight line. Okay, whatever. It's not letting me do what I wanted. Okay, so you're going to look something like that. I know it looks a little bit funky, but as long as you get the general shape is what I care about. The other points that go on your table, I do not really care which ones you put. I would just graph it in the calculator and then hit Control-T and pull up a table and just copy down some of those values. So I'm just going to leave the other ones blank because they could vary depending on which numbers you pick for your table. Okay, your axis of symmetry is that line that cuts the graph in half, so it would be going down here. It is always x equals whatever the x value of the vertex is. So the x value of my vertex here is -2, so I have x equals -2. The domain for all of your problems is always the same. So if you look at this problem and you're like, I have no idea how to solve this, please just write the domain at the very least because it's always going to be the same. It's always going to be -infinity to +infinity. The range goes from the bottom of the graph to the top of the graph. If your graph is facing downwards like this one is, the bottom of your graph can go as low as it wants. So it can have all of the negative y values. So it's going to start at -infinity. and then it's going to reach the highest y value, so I'm climbing, climbing, climbing. The highest y value I hit is here, and that happens at 3. Since I actually hit that point, I'm going to put a bracket around 3. The different transformations are the ones that I highlighted on the equation in the red and blue. So the negative sign that's in the front, the symbol right here, that is going to be a reflection over the x-axis. So that's why my graph is now facing downwards. The 1/4 that's in the front is a vertical compression. A compression happens if your number in the front is a fraction where the top number is smaller than the bottom number. So like 1/4, 2/3, 1/3, those are examples of vertical compressions. In the absolute value bars, you have x plus 2, but x lies, so I'm not going right 2, I'm actually moving left 2. And then the 3 that's in the back is going to move you up 3. Okay, let's look at number 12, our very last one. So again, I'm going to find my vertex first. So I'm looking at these two numbers here. So my h value is positive 3. It always flips sign. And my k value is 4. So I'm going to go to 3, 4, and put a point. From there, it tells me that my slope is 2. So from this point, I'm going to go up 2, right 1, and then up 2, left 1. Okay, so I'm going to put that on my table. Again, hit Control T in your calculator, pull up some other points that you want to plot. Okay, your vertex, we said it's at 3, 4. Your axis of symmetry is always x equals whatever the x value of the vertex is. So we're at x equals 3. That line would cut it like this. That line has an x value of 3. Your domain is always negative infinity to positive infinity. My range, this time the graph is facing up. So the bottom of my graph here is at the y value of 4. So I'm going to put a bracket 4. And then I can go up as far as I want and have all the positive y values above 4. So I'm going to go 4 to infinity. Okay. Your transformations, the 2 that's in the front of the absolute value bars. So the 2 that's here. This is a vertical stretch. Since that number is bigger than 1, that represents a vertical stretch. The x minus 3 that's in parentheses, x lies, so I'm going to be going right 3. And then the plus 4 in the back is going to move me up 4. Okay, so if you have any questions, please let me know in class. We're going to be reviewing on Tuesday, and then you have your test on Wednesday. Remember that your notes packet is due on Wednesday, so please check out the announcement on Google Classroom that has the expectations for that in it. Happy studies!